the section's not right because I ripped that off from Math 3. So it's actually, what did I say, 7.5 for us? So law of cosines. Before we do that, back to law of sines. Law of sines covered 3 scenarios. It was angle, side, angle type information in the triangle, angle, angle, side, and then angle, side, side, sometimes. There was the ambiguous case where it either gave 2 solutions or no solution. I'm not going to sneak any of those in. It will work if those come up, but just remember, eventually there will be issues to that when you see it later on in your math courses. So that's our options for law of sines, given the information we have. Maybe it gives us another side, maybe it gives us another angle, but that at least indicates which one you're going to use. It may not be the first thing you want, so you may have to do multiple steps to it, but there's our indication. Law of cosines will give us 2 other scenarios. It's going to be side, 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 or side, angle, side. And now that kind of covers our 5 different ways we could have them arranged. You're not going to get any that are all angles. We can relate this back to congruence. These were our 5 ways of congruence, with that one typically being HL. But we're not having right triangles, so that's the non-right triangle version of it. So these are the ones we're going to use that given information to solve for something. These 3 here, a squared equals b squared plus c squared minus 2bc cosine a. It takes that and changes for which side you're solving for to give you the other 2. These would be, you have 2 sides and the angle between. So if I look, I'm solving here for a, b, or c, the side. I have the other 2 sides, and the angle opposite to a. So I'm really just going to focus on this one. When I give you the formula for the test, it will just be one of these. You just need to understand how it applies to take it apart for what you need. So looking over at the picture, we know little b, we know little c, and we know angle A. Our goal here is to get little a, and we're going to use that to solve. Now, what if we wanted to find an angle? Because if we had a side, side, side situation, we need to find an angle knowing only the sides. This is where we modify law of cosines. So what we can do, we're going to take this one. I want to get cosine A by itself. So the first thing I get is a squared minus b squared minus c squared equals negative 2bc cosine A. Subtract them over. Now I divide by negative 2bc. And I get cosine A by itself. Now, that tells me here I'm going to figure out whatever all that stuff on the left-hand side becomes, and then use cosine inverse, spits out angle A. I have an answer. Kind of like we saw law of sines yesterday when we wanted an angle. But that's not really clean. That has multiple subtractions in it. It has a negative on the bottom. So what I can do is multiply negative 1 to the top and bottom, really factor out a negative 1, and it really turns into b squared minus c squared, I'll try again, b squared plus c squared minus a squared, changing the signs on the top. And on the bottom, it's 2bc. And this is the form we're going to settle on, the other type for law of cosines. So we took this one, where it's solving for a side. This one is solving for an angle. I'm not worried about you manipulating between the 2 of them. I'll give you this. I'll give you this. You need to be able to solve with them. This one solves for a side. This one solves for an angle.
Can you explain how you redo the bottom?
What I did here?
Yeah, I don't understand how you got to that.
I want to get cosine A by itself.
Okay.
Maybe you don't want to call it cosine A. Call it x. Call it d. Call it some other letter. Make it a blob. Whatever you want to do. Okay? I first subtract these over to here. So instead of a squared by itself, I subtracted b squared and c squared from both sides. So it's here. Then I have this term, negative 2bc. I divide it to both sides, so it shows up on the bottom here, and it's gone from the right-hand side. And then what I did here was factor out a negative 1 from the top and the bottom. By taking out a -1 here, it changes all the signs on the top. By taking a -1 from the bottom, it just makes it positive. But -1 and -1 is really just 1, so I didn't change the whole equation, it just changes those terms on the left-hand side, flips the sign of everything, which makes it a little bit cleaner to work with instead of all subtraction. This would work, it's just a little bit more extra equal or negative signs, where if I write it here, it's just a -a squared. Okay, so as we go through this, I'm really focused on the top one and the one I've boxed in. I could go through and manipulate these and write them out in the other form, but we need to just start seeing the pattern that occurs. You're going to be looking for a side. To find that side, you're going to have the other two sides that you know squared, minus 2 times the other two sides, and then cosine of the angle. Okay, don't get stuck thinking about A, B, and C. Just think about where the parts go. If you look at this, you just say, okay, well, A is the side I'm solving for, so is the other two sides, and there's the angle. Same idea down here. You're going to be solving for an angle. Little b and little c are the sides next to that angle. So you're going to square those. You're going to subtract the one that's opposite to it, and then you divide by 2 times bc. So really the only time that opposite side is used is right there. Okay? We'll pick those up every time we go through. What I don't want you to do is say, oh, that problem is wanting me to find C, but angle C, so I have to go through and manipulate this to be that version. That's extra work. Just start seeing the patterns as we solve through them. Okay? We'll start out with the basics. We'll walk through it. So, here's some triangles to start with. Okay? The top two, yeah, good groan. Way to go. Real happy about that. The top two are the first formula. Okay? The a squared formula. That's the top two. Do those first.
Wait, is that the a squared plus b squared plus c squared?
The top two problems are this type. Okay? So we're doing this type first. That's these two. Because you're solving for a side. These two are the bottom formula I gave you because you're solving for an angle. Ah, all right. Because there's
B under the C. So this would be the B squared and that would be the C squared on the bottom.
kind of, because there'd be cosine of A, cosine of B, cosine of C. Up here, that one would be the B squared, right here, because it's that's little b, it's opposite to B. And this one would be E squared, which is not even one we talked about. So we can put it together. All right, so let me write the one I had up there. It was a squared equals b squared plus c squared minus 2bc cosine A. Now that is the general one. We had that. I'm not solving for side A in these, so we have to kind of use our brains to change and rearrange the parts, but we can do that. It's just getting the pieces in the right place. Okay? I'm solving for a side. Right there. I'm going to use the other parts, the other sides, and that angle to put it together. So for this one, I'm solving for little b, b squared. Don't forget the squared. So, what are the sides I know in this? 20 and 23. Does it matter which one I write first if I square them? No, it doesn't. So let's see, 20 squared plus 23 squared. Okay, minus, I look up here, it's 2 times BC. Oh, it's just the other two sides. All right, well, does it matter which order I write them in? No, 20 and 23. Okay, what's cosine of the angle? What angle?
So why is it B squared equals? I thought we were trying to find A.
Let's go back here. I could use that one right there.
Why?
Because that one's b squared.
Wait, how do we know which one's B? It doesn't matter.
No, because
How do we know
Hey,
which one's B?
guys,
Not a negative.
we don't need to get attached to which letter goes where. I want you to understand the parts. I'm solving for a side. Okay? Little letters are sides. I want a side. It's right here. Side. This is the other side. This is the other side. You square them. Okay? I don't care what letter they are, I just square them. Add it together. Then here is the other side. And the other side. And then the angle. Okay? It follows that every time. I can switch the letters out. The problem on the top right doesn't have A, B, and C in it. It's okay.
Exactly.
We just need to get the parts in the right place. So, there's our setup for the first one.
Is 20 A, B, or C?
Oh. Let's go here. I got 20 squared is 400. Someone help me out. 23 squared?
529.
Okay, that was better. All right. Okay, minus, what are these together? Looks like 460. So that's times 2. 120. Cosine 119. Okay, now there's a critical step here. See how this is multiplication? Yeah, you don't put the 920 with these. Okay, so this becomes 929 minus 920 cosine 119, which is not 9 times cosine 119. That is not correct order of operations. You need to multiply 920 cosine 119, and then you're going to subtract that from 929. Okay? If you do 9 times cosine 119, you get negative 4 point something, which probably, I'm pretty sure, is not a side length. So really it comes out to be 929 and plus about 446. Is that what you got for negative 920 cosine 119? Okay, because it comes a negative. Okay, now that is still b squared.
Mr. Davidson, mine's coming out to 446, but it's negative.
I got the answer.
It's because it's minus 920 cosine 119. So it's minus a negative.
Oh, okay.
So we got b squared is 1375, approximately.
37.
Yeah, then you take the square root, because we look and we go, oh, the side's 1300.
It's a little big.
When the other two sides are 20 and 23. Probably not. Okay, b comes out to be approximately, we got 37? We'll call it 37.1?
37 is 0.08.
We'll round to the whole digit so we don't argue. The next one is also a side angle side. Look, side angle side over on the first. Side angle side over on the second one. Okay, those parts are the same. We're still solving for the side opposite the angle. It's still the same format. The numbers, the letters are changed. That's fine. We just need to use that format to solve for it. It's still going to use this. It's still going to be the same idea here. It's just getting the pieces in the right place. If you're paying attention and you recognize the fact it's law of cosines, which they all are because it's law of cosines right now, you'll get the pieces in the right place. So here we go. We'll first write, what are we looking for? X. So that's x squared. Okay? So I need the other side squared. What side do you want to pick first?
35.2.
What if you hate 35.2 and you like 31.7? Could you write that one first? Sure, you can. You can do whatever you want as long as it doesn't break math rules. All right? The other one's 35.2. Oops, I forgot the 2. Let's go down here. Okay, now, that's the first two parts. Minus. Up here it says 2BC cosine A. But all BC are the sides that I just wrote. Now they're not squared. Okay? Then it's cosine of A, but I don't have an angle A. But wait a minute, I only know one angle. What angle should I write in there? Hey, how about 49? Okay? That's what you got to get to. You get there, and then you go through, you get your calculator out. Please do not solve this by hand. Okay? Okay? Then you use your calculator, you solve it. Okay? Solve it. You could have been about like 27, 27, 28, somewhere in there. This, if you wrote 28, that's good. And when I go in, if you're within a couple decimal places, I'm going to be fine on that. Okay. Part of that is just accuracy in a calculator. I'm not going to penalize you for that, but we're close. Yeah.
27.7 would be okay. Okay.
No problem.
If we always round the whole number, so like,
At the end, you can round at the end. What I'd be careful with would be rounding that 2, 31.7, 35.2, cosine 49. Rounding there would be a problem, but if you rounded at the end, you'd be good.
well, I didn't round that. It was like when I did cosine 49 and then those two together, it came out to 1,264.11 something.
Okay.
So I just took the decimal.
So I'm now going to steal this. Now we're solving for an angle. We're solving for an angle on these bottom two because we only know sides. Let's say side, side, side. So this one top uses side angle side. The bottom one uses side, side, side. Now if you want to find all of the angles, you'll have to do this twice to get two, and then you could use triangle sum to find the third. But right now we're just focused on one angle. Okay? We have different parts here. We have the opposite angle. By the way, I've written it, is the one that's being subtracted. It's squared and subtracted up from the top. The rest are the adjacent angles. And then that angle in the cosine is the one you're solving for. So just like above, don't get attached to the letters, just understand where the parts go. Cosine of the angle I'm solving for equals the adjacent side squared, added, minus the opposite side squared, divided by 2 times the adjacent sides. Okay, those parts just keep going in the same place. You look at the next problem we're going to do. Sides again, find the angle. We just need to get them arranged the right way. So let's go, let's say cosine of B. What are my two sides that are being squared and added? 12 squared, 19 squared, minus 14 squared. Divided by 2 times what values? 12 and 19, the adjacent ones. Okay, for this one, you're going to plug, I'd probably do like top divided by, get the top value, get the bottom value, then get divide. It's going to be a decimal because this is a cosine ratio.
45.
So what is 12 squared plus 19 squared minus 14 squared?
I still haven't figured out the second one.
We'll come back to it. 309. So 309. And then on the bottom we have what? 456. Now cosine isn't going to work when it's bigger than 1. We can see 309 divided by 456 is good. So we now go cosine inverse of that equals the measure of angle B. It comes out to be approximately what? Let's get about 47 degrees. Okay, so we got our setup. 28 and 17 are the adjacent sides. Those are squared. We subtract the opposite side. 15 squared. 28, 17, then go with the 2 on the bottom. You put that in the calculator, it comes out to be about 0.890. put that there. So we get cosine C is about 0.890. Then by cosine inverse, it comes out to be about 27 degrees. Okay, if you got close to that, 27 point something, you're good. What answer did we get?
About 75.
89 degrees. 75. Wow.
Did you get about that?
Yeah, that's exactly what I got.
Okay, now, first thing, opposite the longest side is going to be this one. This is a side, side, side problem. You're solving for an angle. So this is one where it's going to have cosine of x, and then you write the rest of it. This is the second formula we had. Okay, initially we know that. If it was solving for a side, it would have been the first formula because that has the side by itself. So that should get you off to a good start. 10 squared plus 14 squared minus 15 squared over 2 times 10 times 14. Okay, were you guys quick in getting that in? When you looked at the formula, did you get the pieces in the right place? It's pretty easy. Yeah, and that's the key part. From there, turn this into a fraction. Do cosine inverse. What was it as a fraction? Did we get the decimal? How much? 71 over 280. So it's about 0.25. So that was the cosine inverse. We got our angle 75.3. Now, if the question went further and said, find all the angles. Find all the angles, you could then pick another angle, maybe the one opposite the shorter side or opposite 14. Doesn't matter. You'd find that angle, and once you have that, you don't have to do law of cosines again. You just add the two together, subtract from 180. But that's where we could start to combine the steps for law of sines and law of cosines. Okay, so now that's where we go next. Whoa. That's some weird stuff.
Okay, how are we supposed to know when to use law of sines and law of cosines?
Good question. Okay, before I answer that, do you want to copy it down? Then I'll explain it. Okay, so let's just focus on this one. Don't worry about the second one. We may not do that one. We have certain scenarios that work with the different laws. Like we've talked about, law of cosines is your side, 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 or side, angle, side. Law of sines was angle, side, angle, 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 side, or side, side, angle. Sometimes, but for us, always. Okay? So you have to look at what you have to what you solve. When I look here, I have a side, angle, side in terms of information. But that's not going to give me the angle. If I do law of cosines here, what value am I going to get?
BC.
Yeah, I'm going to get
then
this.
You could do that, and then you could do the side, side, side to get angle of x.
There you go. So, he could be the teacher. Okay? So again, as he jumped to, that's going to give me BC because it's a side angle side type problem. Then once I have this value, whatever it is, then I can use, you said law of cosines. You could use law of cosines because you have three sides to find an angle. Okay? Or you could use law of sines because it would be this side, sine of 20, this side is 60, sine of x. Okay? So we may have to do it multiple times. So let's work through this one. First thing we want to find, are you okay if I call this one little a because it's opposite angle A? Okay with that? There's personal information. We're good. So it's a side. So it's a side is by itself. Okay? We're not going to cheat. We're not going to look back at the formula. So we want to find that side. We know it's squared. Okay? What comes next? 60 and 68, okay. Just like that, though?
No, squared.
Ah, squared. Okay. Then?
And then minus 2 and 60 times 68.
Very good.
Oh my god, I'm so sorry.
To sweep the category.
And then you do something else. The cosine of 20. Oh my god.
There we go. Okay, now we can find A.
I thought it was like a fraction.
That's when you solve for an angle. That'll be the second part. So this one is law of cosines using side angle side type setup to get me this. We're trying to find this side. We can't get to x directly yet. We're just going to use what we have to solve what we first can do. It's not the final step. It's first step, and then we'll get there a second step.
That doesn't seem right.
Trying to find a side.
I got 7.
Yes.
Is it only a fraction or are you trying to find a
Because we moved it around so it was just the cosine by itself, and that created the fraction. This is the first formula we got.
You're doing here now.
Okay, we should have got about 23.6. Okay, now, you got two options. I don't care which one you do. You're either team law of sines or team law of cosines. If you go law of sines, if I went law of sines, I would go sine of x over 60 equals sine of 20 over 23.6. Solve the proportion. If I did law of cosines, I'm solving for an angle, so it's the one where it would be cosine of x equals, top fraction is 68 squared plus 23.6 squared minus 60 squared over 2 times 68 times 23.6. That, I'm going to get a decimal, and then I'm going to do cosine inverse of. Here, you're going to do cross product, and you're going to have to do sine inverse of something. It doesn't matter which one you do. You should do one of them, and you should have someone else do another one and see if you get the same answer. That'd be a good way to check. Okay, so what did we get? 60.5. Which one did you do, left or right? Law of sines or law of cosines? What's somebody get law of sines? Yeah. I got 60.4, then 60.5. It's close enough, guys. We're approximating. We rounded to 23.6 early on in the problem. So if you're one of those, you're good. Okay? Really, I'm going to look at it and say, are they between 60 and 61? If you're there, I'm happy. Okay? There's rounding earlier on that's going to throw it off a little bit. You don't have to be exactly to the 10th. I want you there. Now, if you got an answer of like 475, I'd be a little worried. Other things we can look at here, because we got it's about 60.5, we can see that the smallest angle is opposite a smaller side, larger angle is opposite a larger side. It's showing things are in the right place. Angle C will be obtuse, so it actually turned out to be the longest, and the longest are matching, so we should be good.
So would, for the B, would it be cosine negative 1 equals 15, or cosine negative 1, 1580?